this will be the solution for exam 1 from 116 winter 21 on question 14. So looking at section 16.6, so looking at the interference of basically two sound sources, and looking at getting into the topic of interference. So looking at path length difference, so you have got two sources, and if we have a non-zero path length difference, considering is that path length difference equal to a whole integer multiple of the wavelength, that will give us the condition for constructive interference, where crests are landing on tops of crests, troughs on tops of troughs. So we're getting a maximum constructive interference if this condition is satisfied, where the path length difference between the two sources and to the person that or the sort of the detection device that's picking up the sound, if it's equal to a whole integer multiple wavelengths, we get a maximum sound, a maximum intensity at that particular location. If the delta D happens to be m plus a half lambda, an integer plus a half times the wavelength, we would have complete destructive interference at that particular location, and we end up having no sound at that particular point. So that's sort of the key ideas for this question. So I picked a similar context with the sort of two speakers and a student, similar to the student A, B, where student A was in the middle of the speakers and student B was sort of located from one of the speakers. So that's what we have. This is the context here. So two speakers both emit sound that's coherent. That means they're sort of emitting. They're sort of in the speakers are in phase. So when they emit a crest, one emits a crest, the other emitting a crest. One emits a trough. So one emits the other emits a trough. So they're sort of coherent. And I picked a frequency so that the wavelength will be a nice round number. It ends up being 4 meters in this particular case. I think it should have been a pretty round number in the other. I think it was 3 meters in the other version. So a student is located 8 meters from speaker 2 is shown below. If the student hears a maximum sound, what's the minimum distance D between the two speakers? Use 343 for the speed of sound. Okay, so let's think about what we have in the question. So the 8 meters, that's going to be representative of D2, the distance between the person and speaker 2. I need to find out what is the distance between the person and speaker 1, and then I can solve for the D in the actual question using Pythagorean theorem between D1 and D2. So we are given the frequency as 85.75 Hertz. So it's V equals F lambda. So lambda will equal V divided by F. So as I mentioned, I picked some frequency values that would allow us to give us a lambda in some sort of nice round number. So the lambda is 4 meters, and we're told the person definitely has a non-zero path length difference. So D2 and D1 are not the same, and we're looking for the minimum path length difference, or the minimum distance between the two speakers. So that will, for the person to hear a maximum sound. So we're trying to satisfy the condition that delta D equals m lambda. So we know that delta D is non-zero, and we want the smallest value. So the smallest value of delta D will give us the smallest value of the D in the question. So that's what we're referring to, where m equals 1. So I need the delta D to be equal to 4 meters, which means that D1 would have to be basically D2 plus the D1 will be equal to D2 plus the delta the delta D, which is basically equal to D2 plus 1 wavelength. So if D1 is 12 meters and D2 is 8 meters, the path length difference to the person is 4 meters, and that's true for the other version. I think it was 3 meters. So I think the other D1 had to be 11 meters. So then we can basically solve for the D in the question is going to be equal to the square root of 12 meters all to be squared minus the 8 meters all to be squared. So again, using Pythagorean theorem, that D1 is equal to D1 squared is equal to D squared plus D2 squared. So using Pythagorean theorem to solve for the D in the question. So the distance between two speakers, and this is equal to 8.94 meters in this case. So that's sort of what the sort of steps for both versions. Determine the wavelength, knowing that it's a maximum sound, looking for the minimum distance. The adding one wavelength to the to that distance between the person and speaker 2 will give you, in a sense, the minimum distance the person has to be from speaker 1 to give us the smallest distance between the speakers, and then finishing up the question with the Pythagorean theorem to solve for the actual distance between the speakers. Okay, yeah, I'll wrap that question up there and follow up with I'm going to look at questions 15 to 17 as one video, so I'll follow up with that next.